calling. Hello, ladies and gentlemen. I'm Meg Wang from Huawei Data Storage Solution Department. And thanks for Charles for introducing the key technologies of Huawei OceanStor Dorado. What he didn't mention in his speech is most of the technology in his speech are already tested by ESG, a third-party IT consultant and validation community. In ESG's test report, Huawei OceanStor Dorado supports 81 microsecond latency, 100% load balance, and AI management. Thus, ESG recommends to have a closer look on Huawei OceanStor Dorado if you're investing a next-generation all-flash array. Well, there is an old saying in China, words are but words, but saying is believing. Let's come to the exciting part, believe it or test it. In this part, I will connect to the lab to show you some test cases. My colleague Zhou Hui, Data Storage Senior Engineer, will make some demonstration from the lab. He prepared 3 test items regarding performance, reliability, and management. Let's first look at the test environment. Let me hand over to my colleague Zhou Hui.
Hello, ladies and gentlemen. My name is Zhou Hui, Senior Engineer of Huawei Data Storage product line. I'm now in one of our storage lab. This is the test environment I'm gonna show you today. The product for testing is new generation OceanStor Dorado 18,000 system. It's connected to 2 servers using 2 FC switches for network redundancy. 2 servers are configured with 2 draw ports, 16 gigabits per second FCHBS. OceanStor Dorado system is configured with 8 controllers, 12 4-port, 32 gigabits per second FC front-end I/O module. RDMA high-speed links are used to connect the controllers to 2 SSD enclosures. The enclosures have 70 NVMe SSDs, each providing 3.84 TB capacity. On the test host, VDBench is running in a Red Hat 7.2 operating system.
Thanks, Zhou Hui. Now let's come to the first test item, performance. In ESG's report, it is said that OceanStor Dorado supports minimum 81 microsecond latency. Does it? Let's get back to the lab and check it out.
Let's log into the test host. Use VDBench as the test tool to set the test model. I/O size is 8 KB. Read-to-write ratio is 7:3 random. Simulate OLTP service. We then start the propelled performance test script and run the script. Let's come to Device Manager to check out the performance. Instant performance doesn't mean anything, so I let the system running for 30 minutes. Now we can see the latency remains stable at 80 microseconds in the past 30 minutes.
Yes, OceanStor Dorado made it. 80 microsecond latency. I remember the industry average is 500 microsecond. OceanStor Dorado support 80 microsecond which is 5 times better. Then what about the performance after enabling the software features like snapshot? Will there be any performance loss?
As data is increasing at a faster pace, enterprise must consider how to shorten the backup window. To address this issue, OceanStor Dorado all-flash storage use HyperCDP to provide continuous, most frequent data protection with zero performance loss. We use the same test topology and map 2500 GB LANs to the host. Let's first log into the test host and use the VDBench test tool that uses the model of 8 KB 723 random reads and writes to simulate OLTP service. We then start the propelled performance test script to keep delivering 1.1 million IOPS. The device manager shows the system performance is around 1.1 million IOPS. We create a HyperCDP task to protect 20 LAN in the group. Set the policy as a create a snapshot every 3 seconds. Now start the task. We will see each LAN is creating a snapshot every 3 seconds. Go to the performance monitoring page. It shows the performance is stable at 1.1 million IOPS with no jitter.
The result shows that the performance remains stable even after enabling the data protection feature HyperCDP. This is a significant difference between Huawei OceanStor Dorado and other all-flash storage products. Alright, it's getting exciting now. Let's come to the next test about the reliability. Does OceanStor Dorado support 100% load balance and sustains 7 out of 8 controller failure with 0 service interruption? Let's get back to Zhouhui's lab and check it for real.
Let's firstly check the status of OceanStor Dorado 18000 from the Device Management Software Device Manager. The 8 controllers are located in 2 controller enclosures. Now they are all running stable. Let's log in to the test host. Use VDBench as the test tool to set the test model. I/O size is 8 KB. Read-to-write ratio is 7:3 random. Simulate OLTP service. We will then start the test script to keep delivering 1.1 million IOPS at 0.5 milliseconds to 8 controllers. Now the VDBench is showing the running status. We can see the performance of 8 controllers remain at about 1.1 million IOPS in total. Let's come to the device manager, which shows the same performance of 8 controllers, 1.1 million IOPS. Each of the 8 controllers is more or less around 140,000 IOPS. The 8 controllers are 100% in load balancing mode. Now I'm gonna cut down the power of one controller enclosure to simulate the failure of 4 controllers at the same time. From the device manager, we can see the controller enclosure 1 is faulty. 4 controllers are offline now. The rest 4 controllers are continue providing service. The performance drops to about 550,000 IOPS. Load balanced on the remaining 4 controllers. Let's remove 3 out of remaining 4 controllers one by one and see what happens. Now controller enclosure 1 and 3 controllers from controller enclosure 0 are all offline. Online 1 controller is running. From the performance table, we can tell that the system is still running after we put 7 controllers offline and remain only 1 controller online. Now I will put all the controllers back to online to recover the test environment. Okay, the environment is recovered and ready for the next test.
It's quite impressive. So in previous test, all 8 controllers are 100% load balanced, and there is zero service interruption even when 7 out of 8 controllers are failed. Isn't it super reliable for mission critical service? Alright, there is a last test left. This is an easy one. After testing the performance and reliability, you may ask, is it easy to manage OceanStor Dorado? Well, Zhou Hui will tell you.
As more software features are added, complex configuration becomes a headache for IT engineers. OceanStor Dorado aims to provide simple configuration based on a number of intelligent maintenance designs. I will show you how it provisions resource in only 3 simple steps. I'm logging in Device Manager. In this configuration page, you will find there are only 3 steps needed for storage resource provisioning. Step 1. Input the basic storage information. Step 2. Create a storage pool. Select all SSDs and leave other configurations as recommended by default. Step 3. Create a host. After we install the Huawei multipathing software on the host, the storage system will automatically identify the host as Red Hat and add an initiator for it. Then create 4 500 GB LANs and map to the host. Now we only need to scan the LANs on the host. As we can see, the host has already discovered the LAN mapped to it. That's all the test cases I want to show you today. Thanks for your attention. Hope to see you soon.
Thanks, Zhouhui. So only 3 steps, OceanStor Dorado is ready to be used. This saves at least 15% efficiency for the IT engineer.